So hello guys, in today's tutorial I'll be looking at how you can draw more complex circuits with Pro Tools. So last time we looked at how you can draw a basic simple circuit. This simple circuit we drew. We also looked at how you can install the Pro Tools simulation software on your PC. So today, drawing more complex circuits, we also be learning about multivibrators. Okay, so multivibrators are circuits that exhibit the two states in a digital electronics. So we'll be looking at the three types of multivibrator: the astable multivibrator, monostable multivibrator, and bistable multivibrator. So we'll be using a popular IC to achieve this. So this IC is called the 555 timer IC. Let's take a look at the pinout. This is the pinout of the IC. So the 5 timer IC is an 8 pin IC. So being an IC is an integrated circuit, means that there is a circuit inside this place now. Okay, so an IC always have a VCC pin and a ground pin. This is the two pins from where you power this IC. So this is how the 5 timer IC looks like. It's very small. It's a 8 pin IC. So this is the notch, and then the pin labeling is like this: 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the pin 1 is the ground and the pin 8 is the VCC. Like I said, this is where you power the IC. So the power range of the IC is between can power with 5 volts and 9 volts and 12 volts as the case may be. This is pin 2 for trigger. If the IC requires any trigger function is from the pin 2. The pin 3 is the output. Pin 4 is reset. Pin 5 is control voltage. Pin 6 is threshold. Pin 7 is discharge. So without wasting our time, we're going to delve into how we can use them to achieve the different multivibrators. So this is circuit for the Astable multivibrator. So what the Astable multivibrator does is to generate an oscillation. So once you power this circuit, this pin will start oscillating in a square waveform. So it will be oscillating with the frequency dependent on this resistor, this and this. This is R1, R2, and then this is the capacitor. Okay, so let's see how you can actually draw this circuit on Pro Tools. This is the circuit, this is how it looks like. So let's see how you can draw it on Pro Tools. So this is the previous circuit we drew. We can take it out. So, and then we can come here. Alright, so the first thing is to add the 5 timer IC. I've already picked it out here. If you want to pick it, you come here and type 555 and you'll be able to see the 5 timer IC. Alright, so you can pick it out. So this is the IC. So what you need to note is the pin out, the pin connections, and look at how the pins are here, and then make sure you connect it accordingly. So from what we have here, the pin 4 is connected to pin 8. So we're going to run that connection of taking pin 4 to pin 8. And we'll have a resistor from the VCC to pin 7. So let's connect the VCC here. So the VCC here, okay, and then, okay, let me do this way. Let me put it this way. Good. Then the 1K resistor from VCC to pin 7, pick the resistor from VCC to pin 7 to pin 7. So, and the value is 1K. So I'm going to edit the value to 1K. Then I need to pick another resistor, which is the 100K, which is from pin 7 to pin 6. So, as I can see here, the pin 2 is connected to pin 6. So I'm going to loop pin 2 to pin 6. And I have a capacitor. The positive is in pin 2 and the negative is in ground. So I pick the capacitor. So this is the capacitor. So if you want to pick this capacitor, you come to capacitors, then scroll down to radial electrolytic, and then you can pick the capacitor. Look at it here. Look at NUF. Okay. So the positive part, this unshaded portion is the positive part, while the shaded one is negative. And negative is connected with pin 1 to ground. So I connect it with pin 1 to ground. So I'm going to connect the ground now. This is a ground terminal now. Good. I've done every connection, remaining the output, which is pin 3. Okay, I need to edit this resistor here. So the resistor should be 100k. So I pick my resistor, connect to the output. I did this resistor to 100 ohm. Okay, and then I can now connect my LED. So let's simulate the circuit now. So looking at it, I think every other thing has been connected according to what we have here. So you see as the output is going on, off, and the speed is accordance with the capacitor and the resistor we have here. Okay. So if I want the frequency now to increase, I might reduce this resistor now. Let's say I'm going to use something like 10k here now. So using 10k here will increase the frequency while it is oscillating. You see it's oscillating at a very high frequency now. Okay, so let me put back my 100k. So once you simulate it, it will be doing on, off, on, off, on, off. So this is how the Astable multivibrator behaves. So let's look at the monostable multivibrator here. Okay, this is the monostable multivibrator. So the monostable multivibrator creates a kind of a delay. It has a trigger button. You see the trigger is connected to the pin 2 because when you look at the pin out, our pin 2 is the trigger. So once you press this button, it gives it a trigger and it causes a delay here, which is accordance to the resistor and capacitor being used in the circuit. So let's draw out the monostable multivibrator and then let's see how the simulation is. So I can keep this circuit by the side here and come to draw the next one. So drop my 5 timer. Pin 4 need to be connected to pin 8. I need to connect a resistor from VCC to pin 7. So let me connect my VCC. And then the resistor from VCC to pin 7. So, and the resistor is what? 220k. Alright, so our pin 6 is connected to pin 7. Let's connect the pin 6 to pin 7. And then a capacitor 10 UF from pin 6 to ground. From pin 6 to ground. So I'm going to connect my ground here now. Alright, so I've connected the ground. The next thing is to connect the trigger pin. Okay, we have a 10k resistor going to the VCC at the trigger pin. So connect that. And then a push button. And then the other terminal of the push button will be going to ground. And then we now need to connect the output. So to connect the output, need a resistor. Okay, connect to pin 3 and LED at the output. So the value of this resistor need to be 100 ohms. This to the ground, the negative terminal of the LED to the ground. So let's simulate this circuit now. Alright, so if you trigger it by pressing this button, it's going to stay on for some time and it will go off. You see, so it's going to stay on for some time and go off. Okay, so how long it stays before it goes off is dependent on this formula. T, the time, is equals to 1.1 RC. So whereby this resistor is the R and this resistor is and this capacitor is the C. So when you use this formula, you can calculate how long it can stay on and off. So a subsequent time, we are going to design a device that you can use in your home using this Bistable multivibrator. We're going to do a system. So stay tuned and follow our channel if you want to get that project by the time we'll do it. So we're going to design a system using this Bistable multivibrator, a basic home device that you can use in your house. Okay, so having understood how the bistable multivibrator works, let us look at the sorry, this is the monostable. Sorry, having understood how the monostable multivibrator works, let's look at the bistable multivibrator. Okay, so this is the bistable multivibrator circuit. So the bistable actually works like a flip-flop whereby you're using one button to turn a system on and using the same button to turn it off. So that's what we are going to do today, using one button to turn a system on and using the same button to turn it off. That's how bistable multivibrator works. So first thing first, you insert your 5-timer IC, connect your pin 4 to pin 8 and connect your VCC there. Then I'm going to wire this pin 2 now. So let's look carefully how it's being connected. We'll have a resistor that moved from pin 2 to VCC, and then the value is 1.2K. So we edit it to 1.2K. And then we'll have a button at that pin 2. So we'll put our button at pin 2. Alright, we'll have our button at pin 2. And the other terminal of the button goes through a 56K resistor to the output. So I'll have a resistor here from the other terminal of the button to the output, which is pin 3. And the value is 56K. Then pin 2 is connected to pin 6. So I'm going to wire my pin 2 directly to pin 6. And I have a capacitor from that other terminal of the push button to ground at the pin 2 side. So I'm going to put that capacitor. The value of that capacitor there is 1 microfarad. So it will 1 microfarad. So I'll connect it to pin 1. This is pin 1, and I'll loop them to ground. So I will do this. It should be 1 microfarad. Not this, the value. Okay. So now I also have a resistor from pin 6 to ground. So I'll put that resistor here. And the value is also 1.2K. Okay, so we are left with connecting the output now. So to connect the output, we pick a resistor at the output, and we'll connect an LED there, and take it to ground. So, and the LED is going to be 100 ohms. All right, so our circuit is quite ready now. So when you withdraw this, you need to look out for where all these components are supposed to be connected and get it right. So let's simulate. So you see, it was on. When I pressed the button, it will go off. It's going to remain like this if you didn't touch it. If you touch it again, is going to go on and it will remain on. So you're actually using one button to on and off one particular switch. So there is also a project for this in the future. We're going to use the Bistable to develop a system. So with this now, we've been able to develop different multi-vibrator circuits and how they work. And I believe with this, you also understood how to draw various circuits with Proteus and simulate them. Note, note when you are drawing Proto circuits, note the connections, the nodes, and the pins where they are supposed to be connected to. And believe you me, your circuit will be excellent and you get it well. So follow our YouTube channel and subscribe. Like the video for more videos. Thank you very much.